Everybody, welcome back to our unit on matter, and in this video we're going to discuss the last chapter in this unit, and it has to do with the gold foil experiments. Now, before we get started on the gold foil experiment, I just want to let you know that this is just one of several experiments that are historically meaningful. But this particular experiment is actually very good visually for people to understand in terms of how we know what we know about an atom. Atoms are super small, and because they're super small, we don't know what they really look like. Nobody, even now, has ever seen an atom with any sort of microscope. So what we have to rely on is the opposite of direct observation, and that's indirect observation. So since we can't look at it directly and see what's going on, we have to look at the way things behave when they get around them. And then we also have to experiment. We have to keep experimenting, keep experimenting, keep experimenting. And so I'm going to move from here to kind of a blank notebook screen. And on my notebook, I'm going to draw a gold foil. Now, this gold foil is very, very thin. One of the things that gold foil can do is it can be drawn super, super, super thin. If I were to look at this gold foil very closely, it may only be 2, 3, or 4 atoms thick. It's super thin. Okay, so what I'm going to do is I'm going to shoot at this, and this is what they did. This is what Ernest Rutherford did back in the day, is he took a gun, but not a gun that we know of. It's a ray gun that shoots electrons out at this thing. Okay, and then this radiation actually some of it bounced off. Let me change color. Some of it kind of bounced off this way. Some of it kind of bounced off this way. Some of it went through in different directions, but the majority of it went straight through the gold foil. And we knew this because around the gold foil was this detector that would detect the rays coming out of the gun. Okay? And so we saw that all around there was stuff, but most of the energy went right through the gold foil. So what did that mean? What that really meant was that if we look at an atomic view, of what the gold foil looked like, and so I'm going to break out my gold atoms here. And remember, these gold atoms, the gold foil may have only been 3 or 4 atoms thick. So the gold foil, may have only been this thick in terms of atoms. So as that ray went through the foil, it didn't hit anything. So what that made us realize is that atoms in general, the assumption was that gold atoms are similar to other atoms in terms of structure. So what we determined was that an atom is mainly empty space. What there is are these little itty bitty things in the middle of an atom that you guys may have heard this name before, called a nucleus. Nucleus, make sure I spell that right. And that's where the protons and the neutrons are. And then zooming around the outside were the electrons. So mainly, if we blow up what an atom looks like, the gold foil experiment told us that there are protons and neutrons in the inside, and then around the outside there may be an electron here, an electron here, that travel kind of around the nucleus. So if I were a ray of who knows, radioactivity, electrons, whatever, that can pass through an atom undisturbed because it's not going to hit the nucleus here, and the electrons aren't going to get in its way either. So rays can go right through the gold foil, and that, folks, is how we were able to determine that there is a nucleus inside an atom surrounded by the electrons, and that an atom is mainly empty space. This is why the gold foil experiment and a few others are super important, is because up until these guys did this experiment, and let me pull up my PowerPoint, up until these guys did these experiments, we had no idea what an atom looked like. But because of these experiments, like the gold foil experiments that Rutherford did, we now have an idea, or at least back when they did them, of what an atom looked like. If it weren't for these folks doing these experiments, we would have no idea what atoms look like. And so this is really good. And this was done in the early 1900s. So we're talking just over 100 years ago. So it's not like these experiments were done way, way, way back. That's not some information that we've had for hundreds and hundreds and hundreds of years. This information is really just 100 years old, maybe a little more. So that's the gold foil experiment. I hope that clears this up, and have a great day.